Okay, hey guys, welcome back to another Unreal Engine 4 tutorial. Again, we're working with the radial impact, dynamic, and static circles. And again, my name is Devin Sherry, so I'm just going to go over what we did last time. We were able to create the main logic behind our static circle blueprint, where we are able to change the circle's location, generate a random color, and set a random circle scale for our static circle. And then we also set the intensity of our material for the emissive. That's all done within the static circle blueprint, and it takes place when we first play, as well as when we call the update static circle, which we will be doing in our dynamic circle blueprint in this tutorial. And when we play in the editor, we're able to just spawn in different locations and different sizes. So that's working, and different colors are happening as well. So let's go ahead and move forward with our dynamic circle. So let's go ahead and go into the blueprint. And we've already created the components. It's just the static mesh and our root here for it. So let's go to the graph. We're going to start in the construction script, and this is where we're going to go ahead and create basically a reference to our static circle blueprint, as well as a reference to our dynamic circles material. So up by the construction script pin, let's pull this out and call get all actors of class. Then under here, under actor class, we're going to find BP_static circle. And then we're going to pull from the get actors pin and just type the word get, and there's going to be a get array function. We're going to leave the integer here 0. We're going to leave that default. And then what we're going to do is we're going to pull from here. We're going to type in cast2. And the only option should be BP_static circle. So we're going to connect that and connect these two pins. And then last but not least, we have to pull the as BP static circle. We're going to have to pull that out, promote to a variable, and we'll just call this static circle reference. And there we go. Now we have a reference to our static circle blueprint, and we can call its variables that are public, and we can also call its events, any kind of custom events. So now what we need to do is create a dynamic material instance for our dynamic circle. So let's grab the dynamic circle mesh, and then pulling from that, let's type in create dynamic, and you should have create dynamic material instance. So let's connect those. And then the last thing we need to do is pull the return value out and promote that to a variable as well. And we'll call this variable dynamic circle mi for material instance. And that's all we need to do for the construction script. So within this construction script, we are creating a reference to our static circle blueprint and creating a variable for it. And we're also creating a variable for our material instance for our dynamic circle. That way we can reference its scalar parameters as well as its vector parameters. Now that we have that done, we can actually jump into the actual event graph. So the first thing we're going to need to do is create a new custom event. So let's see if this works here. Good. So we'll call this set dynamic circle. And what we're going to do from this set dynamic circle here is we're going to create a new function. We're going to call this function set dynamic circle color. And what we need to do is grab our static circle reference. And from the static circle reference, we're going to type in static circle mi. Or we may need to do get static circle mi. I think the issue here, we're not seeing it because it's not public. So let's go back where it says static circle mi in our static circle blueprint. We'll hit the closed I to make it open, so that way it's public. Compile it again, and then going back into our blueprint for the dynamic circle, we can pull back from the static circle reference, type in static circle mi. Now we have a get static circle mi option. And then pulling from here, we can do get vector parameter value. So essentially what we're doing is we're going to get the parameter value from our static circle material instance for the static circle color, because that's what we named it in our material. So static circle color. Grab this, plug it in. So now that we have the static circle color, we're basically calling that vector, seeing what its red, green, and blue and alpha colors are, or values I should say. And then with that return value, we're going to promote that to a new variable that we're going to call static circle color. So now we have the color of the static circle put into a variable. And what we're going to do now is take the dynamic circle material instance variable, set the vector parameter value, And the parameter name, as we named it in our material, should be dynamic circle color. And then the value is going to be the static circle color. So we're going to get that and plug it in. And we should just have to plug it up here. And that's it. So essentially what this function is doing is it's getting the value of our vector color for the static circle and then making that a variable and then setting that variable to the dynamic circle color so that these two materials will share the same color for both circles. So let's compile and go back to our event graph. And then all we have to do is just drag out that function, just plug it up to the set dynamic circle custom event. And now we're able to have both both circles change color to the same color. So next what we need to do is we need to set the size of the dynamic circle. So to do this, we're going to create a macro. So let's hit plus macro. We're going to call this set size of dynamic circle. And all it needs is two executable pins, one for the input and one for the output. So the executable pin for the input, we're just going to call it in. And then the executable pin for the output, we're just going to call that out. And basically, when we set the size of the dynamic circle, we want it to be either bigger or smaller than the static circle size. So what you need to do in order to get that kind of randomized is we're going to right-click and look for the random integer and range node. Whoops, not that one. Just the normal random integer and range. Minimum value is going to be 1. Maximum value is going to be 2. So each time this macro gets called, it's going to return either a 1 or a 2. And then we want to compare that. We want to see if that's going to be equal to either 1 or 2. So we'll just do 1. That's all that really matters for right now. You can make it 1 or 2. It's still going to be like a 50-50 shot. But then what we need to do is grab the Boolean output pin of that comparison and create a branch. And then we plug that branch into in. And so if it is equal to 1, we want to set the dynamic circle to either be smaller or larger. But if it's false, if it's not equal to 1, then we want to either make it larger or smaller depending on what we're doing. So let's go ahead and start out with the true portion. That's where we're going to make the dynamic circle smaller. So let's create another macro. We'll call this set small dynamic circle. And again, this just needs an executable pin for input and output. And we'll name it in and out respectively. Let's move the output out of the way for now. And what we're going to go ahead and do is we need to grab a static circle reference. And then we need to get the static circle mesh. We need to get the scale of that mesh. So let's pull out again here and do get world scale. So now we're getting the scale of the static mesh, and this one is going to make our dynamic circle smaller. So what we want to go ahead and do is pull from this vector, hit the divide key and get the vector divided by float. And what we're going to add to this float is a random floating range. And a range, the minimum is going to be 3, the maximum is going to be 4.5. And we're going to plug that up. And now what we need to do is get our dynamic circle mesh, pull from that a set relative scale 3D, connect that to the input, and then the vector results of this division will go into the new scale. And then we can plug the output into the end here. So when this gets called, we're basically getting the current scale of the static mesh for the static circle and dividing it by a number that's between 3 and 4.5. So it's going to be smaller than the actual static circle mesh. So that's all we need for that one. Let's go ahead and go back to our set size of dynamic circle macro. And let's grab the set small dynamic circle macro, pull it in, connect it to the true. Now we're going to do almost the same thing, but we're going to have to make this the scale larger. So let's create yet another macro. We'll do set large dynamic circle. And again, two executable pins, one called in, the other one called out. And we can actually kind of copy and paste this section here from our set small dynamic. The only thing we're going to do differently is instead of dividing, we're going to multiply. So pull from the vector here, so we'll do vector times float, plug in the float, plug it up, and we are going to change these values. Instead of a minimum of 3, we're going to do 2, and instead of a maximum of 4.5, we're going to make it a 3.5. And we just need to plug the output back in here. We can compile, and then go back to the set size of dynamic circle, bring in the set large dynamic circle, plug it up to the false. And now we can move forward, and in order to move forward, we do need to make a new variable. So let's make new variable. It is going to be a Boolean, which is our default here. We're going to call it b is dynamic circle small. Compile, keep its default value to false, and then we're going to alt left click drag it out to set it. And so if we set the small dynamic circle, we're going to pull that out and call this true. And then when we make this a large circle, we're going to set this to false. And then all we really need to do is just have a really short delay. So let's hold down the D key and left click to make a delay. We'll make it about 0.5 seconds. Plug these both in. And then grab our output, and then just connect it to the delay. Let's compile that. And then let's go back to our main event graph. And then let's grab the set size of dynamic circle macro. Plug that up. And when we call the set size of dynamic circle, it chooses between 1 and 2, depending on which number it is. It will then call the macro to make the dynamic circle smaller or larger than the current size of our static circle. And then set that variable. If the dynamic circle is small or not, it's going to set it to true or false. So now, with that macro created, we now need to actually make a timeline that will then be used to animate the dynamic circle. So let's right click, let's filter for timeline. We'll call this timeline scale dynamic circle. Double click on it to open it up. Let me remove some of these macros up top. Now in here, we're going to keep the length of this timeline to 5 seconds, but we're going to add a new float track. And this float track we're going to call scaling curve. And then we're going to shift and left click twice to create 2 keyframes. The first keyframe is going to be at a time of 0 and a value of 0. And then the second is going to be at a time of 5 and a value of 1. And then you can hit these 2 zooms here. One's zoomed to fit horizontal and the other one's zoomed to fit vertical. And all we have to do here is just control left click both of these and then right click on one of them. Change its key interpolation type to auto just so we get a smoother curve. And that's it for this timeline. So let's exit out. And now we see this float output for our scaling curve. That's something that we're going to be utilizing right now. So we're going to need to create a new macro. So let's do a new macro. We'll call this dynamic circle scaling. And for the input pins, we're going to again need an executable. We'll call this in. But then we're going to need another input pin. One's going to be a Boolean. And we're going to name this B is dynamic circle small. And then we're going to need one more input pin. It's going to be a float. And we're going to call this scaling curve. And then for the output, we just need another executable pin in case we need it, and we'll call it out. So with those in place, let's compile, go back to our event graph, let's drag out that new macro for our dynamic circle scaling. Let's connect it to the update. And what the update does is that it's constantly calling this as it's updating from 0 to 5 seconds and whatever value that we're adding to that float scaling curve. And then connecting the scaling curve to our scaling curve input. So basically we're getting the 0 to 1 value as time goes on over 5 seconds. That's going to be called into this macro. And then for the B is dynamic circle small, for that Boolean input, we're going to get the B is dynamic circle small Boolean and just connect it up. So that's in place. So now we can actually go back into our macro here. And we're going to have to do a couple pieces of logic. So first, let's move the outputs out of the way. Let's drag from our Boolean input here and just call a branch and connect that up. So again, if the dynamic circle is small, we want to go ahead and multiply it so that if it's smaller, we want it to get bigger. If the dynamic circle is bigger, we want it to get smaller. So that's the logic behind what we're doing next. So let's first get the relative scale 3D of our static circle. So we need to get the static circle reference, pull from that a get static circle mesh, and then pulling from that, we're going to do get relative scale 3D. So we're kind of doing layered calls here, so hopefully you guys don't get confused. And then what we're going to do is multiply this by 3. So do a vector times float. So we're basically getting the current size of the static circle, multiplying it by 3. And then what we need to do is create a linear interpolation for our vector. And the alpha is going to be the 0 to 1 value. The vector result of this multiplication here is going to be our B value. Our A value is going to be the dynamic circle mesh. And then get its relative scale 3D. That's going to be our A. So basically what this is doing is saying, hey, let's get the size of the dynamic circle mesh, and we're going to, over time, over 5 seconds, we're going to make it the size of our static circle mesh times 3. So the end result is that the dynamic circle is going to get larger. So let's line these up, make it as organized as we can. And then last but not least, we have to take this return value, and we're going to have to take the dynamic circle mesh and set relative 3D scale. And then the return value here is going to be the new scale. And then all we have to plug in now is the true into the set here. And now for false, we're going to have to make the dynamic circle get smaller. So the logic is going to be almost identical, so we can copy this section here. But instead of multiplying, we're going to be dividing it by 3. And then connecting it to B. And then the alpha pin is going to be our scaling curve. And then we can copy the set relative 3D scale that we have here. Plug in the return value into the new scale. And then the false is going to go into the main executable pin of that set relative to scale 3D. And then all we have to do at this point is grab our outputs and just plug these up to the output. We can compile that, and now we have that functionality right here ready to go. So now what we need to do is, because if this timeline finishes, if this goes from 0 to 1 and we never click the circles, that means that we basically missed our opportunity to score any points in that round. So we need to have some logic for the finish when this is completed. So let's create another macro. We'll call this finished timeline reset. And this just needs an in and out executable pin. And what we need to do, because whenever we create a timeline, we're given a timeline variable. So we have the scale dynamic circle variable, and from here we can actually pull from it and call stop. So when it's finished, we're going to say, hey, let's stop overall. Let's stop this timeline just in case. And then at this point, we know the player has missed their opportunity to score points. So let's grab a print string, and let's have it print the word miss. And then we're going to create a delay. So let's pull a pin out, type in delay. This delay is going to be about 0.75 seconds. After that time, we're going to reset the playback position of our timeline. So let's go ahead and get the scale dynamic circle reference variable. Type in set playback position, and we're going to leave it to its default 0. So we're basically resetting the position of our timeline back to the beginning at 0 seconds. And now we can actually grab our static circle reference. Before we do that, I want to go ahead and bring back to our static circle blueprint. We have where it says update static circle. That's where we get all this logic, and that's pretty much where everything starts. In our blueprint for our dynamic circle in the finished timeline reset, we're going to call that event. So let's grab the static circle reference, pull from that the update static circle, and just plug that up. And now we're going to create a new variable. Again, it's going to be a boolean. We're going to call this bCanInput. And what this variable is going to control is the player's ability to click or not to click. Because we don't want the player to be able to click multiple times within a given time frame. We want them to be able to click once and then not be able to click again until those circles reset and the round starts over again. So at this point, we want them to be able to input. So let's Alt left click drag that out and make it true. And then last but not least, we just need to connect that back up to our output. So again, once the timeline finishes, we're going to stop that timeline. We're going to tell the player that they missed. We're going to wait about almost a second. It's at 0.75. After that, we're going to set the playback position of our timeline back to 0 seconds. And then we're going to update the static circle again so our game starts over. And then we're going to make sure that the player can input. So let's compile that. Go back to our main event graph. Let's grab the finish timeline reset macro and just plug that up to where it says finished. So with that in place, we just have to do one last bit of series of logic here. I'm going to cut this video in half, so we're going to stop this video right now. The next video, we're just going to finish up this dynamic circle blueprint and then do some final touches in between the two blueprints for the static circle and dynamic circle, and then we're going to see our game being played. So again, my name is Devin Sherry. I want to thank you guys for watching. I'll see you in the next video.